So in this unit, we are talking about two equations that are living together on the same graph, and our job is to figure out when they intersect, if they intersect at all, or if they are always intersecting because they are the exact same graph. So we have four options that we're going to see in this unit. We could have no solution, meaning they never intersect at all. We could have one solution. Typically that comes from two linear systems, but I will show you some examples of one solution and two solutions in just a moment. And then infinite solutions means they're always intersecting. They are right on top of each other. They are the exact same line or curve. So here are some examples of no solution. Parallel lines have no solution because they never intersect. They're never going to touch. I could have an exponential function and some type of linear function. The linear function could also go this way. They will never intersect. I could also have a quadratic and some type of linear function. Those are all no solution examples. Some other solution examples. One solution, I could have two linear functions that intersect once. Another possibility, if I had an exponential function, let's say, that goes like this, and then a linear function that goes this way, that would also be one solution. It would be that point right there. Here we have two solutions with a quadratic. That could also happen if the linear function went this way. That would also be two solutions, there and there. For these types of questions that we're going to go through today and tomorrow, let me actually get that straight. There we go. We're going to solve this algebraically. That means we don't get Desmos. So our job is to come up with some methods of solving where we don't need a calculator because we can do it by hand. So what we're going to do first is substitution, and it's exactly how it sounds. I replace one thing for something else. So here's a couple examples. This first one, you'll see they're both in y equals format. So I can replace y with y from the other equation. So I'm actually going to take this and replace y in the other equation with negative 5x minus 17. So I'll have negative 5x minus 17 is equal to negative 3x minus 3. And now I've got one equation, one unknown, and I can solve for x. So I'm going to add 3x on this side. So I have negative 2x minus 17 equals negative 3. Going to add 17 on this side. Got negative 2x equals 14. Dividing by negative 2 tells me that x is negative 7. So now I know what x is. I can substitute back in here into one of these equations and figure out y. So I'm going to take this. Doesn't matter which one I substitute into. I'm going to choose the second one. It has smaller numbers. So I'll have y equals negative 3 times negative 7 minus 3. Well, 3 times 7 gives me 21 minus 3. So this will be y equals 18. So my solution is negative 7, 18. So here's our second example. Now you'll notice one of these is set equal to y, but the other one is not. So I know that y is equal to this expression, so I'm going to replace it in my second equation. So I'll have negative 2x minus 3 times, and I have to be careful and put this in parentheses because it's this entire quantity that's replacing y. So I have 6x minus 11, and that's all going to be equal to negative 7. So I'm going to refocus this really quick. That's better. So I've got negative 2x minus, I'm going to distribute negative 3 to both terms inside. So I'll have negative 18x plus 33 equals negative 7. So I'm going to subtract 33. And I'm also going to combine these like terms. So negative 2 and negative 18 are going to combine to make negative 20x. And negative 7 and negative 33 combine to make negative 40, which tells me that x has to be equal to 2. Now I know what x is equal to. You could choose to come here and substitute x in and find y that way, but I already have here y equals, so I'm going to take 2 and substitute it over here. So I'll have 6 times 2 minus 11, and that's going to be y. 6 times 2 is 12, so I know that y equals 1. So my solution point is 2, 1. Got 2 more examples for you. Same scenario as the last equation. I'm going to replace this with y. Now there will be times when you'll see x equals as an equation. That's not going to change anything that we're doing here. It's the same exact process. I would just be replacing x instead of y. So I have 6x minus 3 times this whole thing, 2x minus 2, and that's equal to 8. Going to distribute this negative 3, so I have 6x minus 6x plus 6 equals 8. Now you should be feeling a little uncomfortable right now because that's going to turn out to be 0. And I'm going to end with a statement that says 6 equals 8. And last time I checked, that is false. Since this is false, and that's a not true statement, that tells me this is a no solution scenario. So our answer will be no solution, because this is not true. There is no point that will satisfy both of these equations. They will never intersect. And our last example looks like this. I'm going to take this and replace where I see y. So I have 2 times that whole statement minus 4x equals 2. Going to distribute that. So I'll have 4x plus 2 minus 4x equals 2. Well, those 2 will create 0. So I'll have 2 equals 2, which is true. Since this statement will always be true, I know that these 2 equations are identical. This is infinite solutions.